Do some more factoring. Yesterday we talked about difference of two squares, correct? All right, so difference meaning you had a minus inside of it, and then two squares, you had two things that are being squared. Well, today what we're going to do is the difference, just shorten that, of two cubes. And we're not just going to do the difference of two cubes. Remember on the difference of two squares, I said there's only a difference of two squares factoring. There is not a sum of two squares factoring. But on cubes, there is a sum, so we're going to learn both of these. But they're kind of the same. I'll just show you a little trick to remember the sum of two cubes. Well, what does that mean? That means it's going to look something like this. Difference of two cubes, you're going to have a subtraction, right? And then you're going to have something, call it x, that's being cubed. Then you're going to have something else that's being what? Y, which is being cubed. You with me? So we're going to be able to factor something like this. We're going to learn a little, well, it's not so little, but we're going to learn a formula to do this. All right. So really, it's just basically just plugging and chugging into a formula. This is really not that hard. There's not a whole lot of thinking involved in this. It's just a matter of throwing numbers into a formula, but you got to memorize a formula. That's the thing. Okay. And you will have to memorize a formula. I'm not going to give it to you. All right. What would the sum of two cubes look like then? It'd be x cubed, not x3, x cubed plus y cubed. What teacher ever let you say x3? Nobody. All right, not me. Watch, x cubed minus y cubed. Let's do the difference first. Now you're going to see here that the difference of two cubes and the sum of two cubes, the formula looks really, really close, except the signs, some of the signs, not all of them, some of the signs are just a little bit different. Okay, so it's two sets of parentheses, but one's a little bit longer than the other one because I've got three things in the second one, I only have two things in the first one. All right. First thing I'm going to do is start with the signs first. Now here's a little way that I remember this. I don't know, I just made it up. It's nothing spectacular, but I call this the same, this sign right here. There's two things in here, so there's one sign in between the two, okay? So this sign is going to be the same sign as this. This one's going to be the opposite sign as this. And then the third one is going to always be positive, okay? So let's put the signs in. SOP, can you remember that? SOP, same, opposite, positive. That deals with the signs. So this sign right here is going to be the same sign as you have in the middle right here. So what sign is that going to be? Give me a sign. Right, subtraction, minus. Okay. This one's going to be opposite that sign. So this is going to be what? Plus. And then this one's always going to be what? Plus. You get it? So when it's a difference of two squares, it's always same, opposite, positive. Now look, we'll kind of do the sum of two cubes. I said squares, I meant cubes. The difference of two cubes is same, opposite, positive as far as my signs are concerned. If I did the sum of two cubes, everything starts looking the same. We'll plug stuff in there in a minute. But let's just deal with the signs right now. That's the first thing you should write down. So again, it's still same, opposite, positive. But it's the same as this. So what's this sign going to be right in between here? Plus, right? And then what's this one going to be? Minus. And the third one's always going to be positive. You got it? So I just remember same, opposite, positive. I think that's easy to remember, don't you? And again, I didn't see that in a book or anything. I don't really have it patented or anything, but or copywritten. But it just remember, same SOP, same, opposite, positive. Now let's put some stuff in here. Watch. You put an X and a Y right here. Can you remember that? It's not too hard so far. Now watch, if I was to multiply these together, I'm going to get x cubed. So x times what is x cubed? X squared. So you put an x squared here. Okay? And then, right here, watch, I don't even put the middle one just yet. I'll put the last one here. So watch, y times what is going to give you y cubed? Y squared. So you put a y squared right there. Again, it's just a matter of memorizing this. And this is how I remember it. I always put my parentheses, I put my signs, I start off putting an x and a y here, and then the next thing I do is I put an x squared here and a y squared here. All right? In the middle is just xy. It's not xy squared, it's just xy. All right? Now, you say, why does that work? Well, it works because it works. If I wanted to, I'll tell you what, I'll do this in red. I don't usually do this, but I just thought of this. If I wanted to, I could multiply this through, and let's see what I get. All right, let's just do it real quick. X times x squared is x cubed. That's going to be what? Plus x squared y. You following what I'm doing? I'm just taking that x and multiplying it by everything in this parentheses. Take this x and multiply it by, that's supposed to be a squared. It's kind of weird looking. Multiply it by this, what is it? That's xy squared, correct? And then do the minus. So it's minus what? X squared y. See that? And then minus xy squared, yeah? Okay, and then minus y cubed. Does that, it's supposed to be cubed. When I'm writing small, it's not that neat. Okay, so it should equal this. That doesn't look like all that stuff equals this. Well, think about it. Watch. X squared y minus x squared y. What happens to those two? Add up to 0, don't they? This is xy squared. This is minus xy squared. What happens now? They add up to 0. Look what I'm left with. X cubed minus y cubed. So would you agree that this does equal this thing right here? Absolutely. Okay. Now, would you have ever come up with this from this? Probably not. All right, but that's okay. As long as you know that when I multiply these all together, I will end up with this. So if I wanted to factor this, if I wanted to take this and factor it, say what times what is equal to x cubed minus y cubed, this would be it. X minus y times x squared plus xy plus y squared. Now, if I was going to memorize this, do I sit there and say, okay, it's x minus y times x squared plus xy plus y squared? Do I memorize it like that? No, I don't anyway. I'm a terrible memorizer. I'm terrible at memorizing stuff. So I try to think of the easiest possible way to memorize stuff. The way I do that is just go step by step. Okay? Don't memorize the whole thing from left to right. First thing I do is I put my parentheses. Then I put my signs. Same, opposite, positive. You with me? And then I just fill the stuff in. What goes here? X and a y goes here. Then what goes on the ends to the second one? X squared and y squared. And then what goes in the middle? I just take that xy, multiply them together, and xy goes in the middle. There it is. So that's the difference of two cubes. That's the sum of two cubes. I'm not going to multiply this through. Do you believe me that it would work? Sure. Okay. You saw it worked here. It probably works here. And if you don't trust me, you could always do that yourself and see if it does. All right? There it is. Memorize both of these. It's really not like memorizing two separate things, though, is it? It's like memorizing one thing, and you just got to keep the signs straight, you know? And how do you keep the signs straight? Same, opposite, positive, S-O-P. Soap or sop, whatever you want to call it. Everybody got it? Yeah, probably sop. Put a little bar over it. That's soap now, isn't it? Okay. All right. Bar of soap. There you go. All right. So how in the world are we going to use this? Well, I'm glad you asked. Let's do an example. Okay, here we go. Let's figure out how we use this thing. Okay, how this thing is useful to us. So here's my first problem. It says to factor, and here it is. It's x cubed plus 27. This is what we want to factor. We want to find what times what equals x cubed plus 27. Well, look at it. There's a plus in the middle. Is something being cubed here? Sure, x is being cubed. Is there something being cubed here? What is? 3, right? 3 cubed is 27. All right, so watch what I'm going to do first. So, is it a difference or a sum of two cubes? Absolutely. Which one is it? Sum or difference? It's a sum because you got a plus right there. And it is. You just got to recognize it. So you look at it and you're like, okay, which one of these factoring problems is this? There's a plus in the middle. That's being cubed. That's being cubed. Or something's being cubed, I should say, to get that. And so I'm going to use this one right here. This is the sum of two cubes. What I'm going to do first, though, I'm going to rewrite it. Did you notice how this is x cubed plus y cubed? It's not really written y cubed or something cubed here, is it? But let's write it like that. So what would it be? It would be plus what? 3 cubed. So, in this formula right here, what's my x? Well, it's x, isn't it? Okay, it just happens to be the same letter. What's my y, though, over here? It's 3. So anytime you see an x, you stick an x in there because of this x right there. Anytime you see a y in this formula, what do you put in its place? A 3. Make sense? That's all there is to it. Watch how easy this is. Now, I'm putting this here for safekeeping just so we remember it because it's the first time you've seen it. But on a test or quiz, you're going to have this memorized. All right? So let's do it. Put your parentheses and go in the order that I did. I think it's an easy way to memorize it. Let's put the signs in there. Same, opposite, positive. So what's this going to be? Plus. And then opposite would be minus, and this is always going to be positive, plus. Okay? What goes here and here? I mean, try not to look over here. I know it's there, but you got an x, y, and then, I'm sorry. Yeah, let's just, yeah, I guess you could, I tell you what, this is what I would do. If, you know what? I'm getting rid of this. Boom. You don't need that, do you? What would it be without the 3 in there? Y, and this would be what? X squared, and this over here would be y squared, and inside there is just xy. Now we can plug it in. This is what I would do, at least in this first worksheet when you encounter these things. I would write the formula down every single time because that helps you memorize it. Right? The more you write it down, the more easy it is to remember. So let's put some stuff in here. So what do we get? Actually, let's do it like this. There's plus, minus, plus. And this is going to be x plus y. What's my y? It's 3. What goes here? X squared, right? What goes here? 3 squared, which is 9. 3 squared, not 27. Do you say 27?
No, I said 9 first.
Okay. Yeah, it's 3 squared. It's the 3 it's being squared, so it's 3 to the second power, which is 9. And then right here is the x times the y. This times this. What is that? 3x. Okay? There we go. Now look, this looks like a binomial, doesn't it? Now, if this could factor, it's trinomial. I'm thinking 2 binomials, they multiply together. This is a trinomial factoring, but if you look at this, does this thing factor? Can you get 2 things that multiply together to be 9 and also add up to be negative 3? Well, you only have 2 choices. You got 9 and 1. Is there any way you can get a 9 and a 1 to add up to be a negative 3? No. What about 3 and 3? Is there any way 3 and a 3 can add up to be negative 3? No. So this will not factor, will it? Look for it, though. I mean, there are times, I'm not sure how often, but there could be times where this could factor a little bit further. Okay? So always look for that.
That's your answer?
That's your answer right there.
As far as you can get.
Yes. That was the whole point of saying this, because this won't factor any further, right? So if it doesn't factor any further, you can't do anything else with it. That's all you can do. All right, and that's it. That's factored. What does it mean to factor? It means what times what is equal to that thing we started with. If you wanted to, you could do this if you wanted. You could take this x, distribute it through, take the 3, distribute it through, add up your like terms, but guess what you're going to get? You're going to get x cubed plus 27. All right?